Hello there, my name is Thomas. I'm here today to talk about standard deviation of stocks and time scaling of standard deviation. This is a topic that has been requested on investmentexcel.com, and as such it's in the category popular topics on the site. I will show you today how to use on a historical time series Excel's built-in functions of standard deviation and variance, and I will show you how to manually calculate it so you know what's going on. And then at the end I will show you how to scale the risk measure of standard deviation of stock so that we can rely on a monthly based time series of data to interpret also annualized figures. So this video and the Excel workbook are both available on investmentexcel.com, of course, but also on spotify.com. Let's look at a time series of daily returns of Microsoft Inc. And we got it here, 25 observations, 25 trading days with a return. Now let's just start without looking into the formula, which is up here in the right corner, but let's just have Excel calculating the variance, which is done by this formula bar.s on the time series. And as you might already know, the standard deviation is linked mathematically to the variance by the square root of the variance. So I take the square root of the variance here, but in fact also the standard deviation has a built-in function, and we will find it here. So it should give the same result, and it did. Before I do the manual calculation, let's just recall how the actual formula looks like. And the formula I have presented here is the sample variance formula. Today I will not go in much detail or touch much upon the difference between the population variance and the sample variance. We will stick to the sample for today, but please refer to other session on population versus sample variance and standard deviation. All right, not so much talk. Let's look at the formula. And on the right hand side here, we have a large sigma, Greek large sigma, which means mathematically that we sum over. And in this case, we sum over the observations from 1 to n. And in the case with our time series, we sum from 1 to 25. And in that summing, we do for each I, that is for each observation, each day in this case, we do the following. We take the actual observation minus the average of the sample, denoted by X with a line above. And then we have to square it. If we didn't square it, imagine if we had exactly the same plus and minus difference, they would net out